Hello, hello! Alright, in this quick video we are going to see how we will algebraically verify if two functions are inverses of each other. Okay, so let's just remember a couple of things really quick. Let's draw our function diagram. So recall, this is our domain over here for f, and we have a value a here. And a is going to get mapped to b, so into our range. We draw this diagram right here to represent that f is going to take a to b. Another way to write that is f of a equals b. Then the inverse function takes that b back to that a. So that's our f inverse. And we would write f inverse of b equals a. And because of that, if we started at a, then traveled to b, and then went back to a, that's why we call it that undoing function. Okay? Well, let's talk about how we could talk about this undoing property with algebra or algebraic notation. What if I started at a and then I composed it with f inverse? Okay? So this means I'm going to plug in a, and guess where I'm going to land? At b. So that f of a is replaced with b, and then I'm going to apply f inverse to it and land back at a. Right? So that's how I'd write what we just described algebraically. So to paraphrase, f inverse of f of a is just a. Well, what if I went the other way? What if I started with b? So what if I started at f inverse of b and then applied f to that? Okay, so I'm at b, and f inverse takes b to a, so I replace the f inverse of b with a, then I apply f to it, and guess where I land? Right back at b. So we would write f of f inverse of b equals b. Alright, now this is actually the property that inverses have, so let's restate that. Let's switch to green. This is the inverse. How about we put it so you can see it? Function, or this is a inverse function property. If f composed with this function f inverse of x equals x for all x in the domain of f inverse, and f inverse of f of x equals x. In other words, wherever I started, I apply both of my functions and I land back where I started in both cases, and this is true for all x in the domain of f. Then, if those things are both true, then f and f to the negative 1, or f inverse, are inverses of each other. Okay, well, let's see algebraically an example. Okay, so let's just test. Let's let f of x be equal to 2x minus 1, and g of x is going to be equal to x plus 1 over 2. My question for you is, are f and g inverses of each other? Okay, well, let's see. What we would have to show is that if I need to show that f composed with g of x equals x, and g composed with f of x also equals x. In other words, I need to compose them in both orders, and wherever I start, once I apply g and then f, I land back where I started. Wherever I start, once I apply f and then g, I better land back where I started. They better both undo each other, and if that's the case, then they're inverses of each other. So let's see what happens in our particular case. So f composed with g of x equals f of g of x. which equals f of, what's g of x? X plus 1 over 2, right? I'm just replacing that g of x with what g of x is. And now I apply this to my function f. So it's going to be 2 times whatever's in that set of parentheses minus 1. And if I reduce, I end up with, let's make sure you can see, x plus 1 minus 1, which equals x. Now I'm not done. All I've shown is that f composed with g equals x. So let's go the other direction. Let's look at g composed with f of x. So this is equal to g of f of x, which is equal to g of 2x minus 1. I just replace my f of x with 2x minus 1. And now I apply the g's rule to this 2x minus 1. So it's 2x minus 1, which you can't see, so let's try that again. 2x minus 1 plus 1 over 2, because recall that g of x, whatever was in its parentheses, added it to 1 and then divided by 2. So this is in its parentheses, so add it to 1, now divide it by 2. And let's reduce. Those 1's up here cancel, and I'm left with 2x over 2, and that equals x. So I have shown that f composed with g of x equals x, and g composed with f of x equals x. G composed with f of x equals x, and f composed with g of x equals x. Thus, this is the final piece, f and g are inverses.